Okay guys, it's me Imad from Nelson Darwin Park Tech YouTube channel. Today we are going to learn about how to add the noise within any signal inside the Python. So how we can do it? First of all, we have to import certain libraries in order to generate a signal, and obviously for noise we also need these libraries and certain packages from these libraries. So first we need to import the most important library, that is called as the mateplot lib.pyplot. Pyplot is PLT. Okay, why we need to import such a library? Because of the fact that this library is solely responsible for to plot the signals. Okay, just like the MATLAB, as you maybe you have heard about the MATLAB for signal processing. So this library is just like that MATLAB one. After it we need to import the second library, that is called as the NumPy. As NP and as PLT simply means that as these names are very lengthy, like mateplot lib.pyplot. So rather than writing all this, we just need to write PLT and NP for NumPy and this thing. So they will act the same. Okay, now after this thing we need to import third library, that is called as random. Okay, and what this library is all about? Random, obviously from the name we can see that it will generate certain random things like noise or samples, random samples, and like this. So this is one of the library. And in the last we need to import one library, that is called as the time library. Time library is for like to create the delay for our commands, if you want to insert certain delays within the commands, then we can write. Okay, now after, as we have to define, as we are going to make certain signal, sine signal, but before that we have to declare the sampling frequency. Frequency sample is equal to 800, we have written there. And what is meant by this sampling frequency? It means that in 1 second we are reading the signal for 800 times. Okay, there are 800 samples of this signal within 1 second. After this, the sampling frequency, we will just write the simple frequency of the signal. Now this thing is a bit different. Okay, from sampling frequency, this frequency is the number of cycles per second. The whole cycles, it is not related with samples, it is for the whole cycles of the signals. Now after it we will define the samples, so it must be 700. Now 700 simply means that our samples will start from 0 and ends at 700. Okay, so you are not supposed to confuse it with the sampling frequency. Sampling frequency is something else and number of sample is something else. Okay, now we need to create a random array, so we will write np.range and samples. So what is a range of samples? It simply means that a range is a function which used to make a vector for us. Okay, vector of word. It is just like the linear space command in MATLAB, that it will make what's called as the vector which starts from 0 and ends at 700, and its elements are like having the same difference between each other, like the first one is 1, 2, 3, 4, 5 and up to so on, and like this. So x underscore input is equal to np dot range and samples. Okay, so np dot, so it is samples, and it will create. Now we will create our noise. So we will write a variable that is called as noise, and for all the noise creation process we have to import certain functions on the right hand side of this is equal to operator. So we will write 0.008 or 0008. Okay, this is just a constant to be multiplied with np dot is array. Okay, dot. Okay, now is array, so we will write random dot sample. Okay, random dot sample range 0,1000 and comma samples. Now this is a command especially for to create the noise signal, a noise generation command. Okay, so what it used to do, first you can see that this is our range function. Again it will create 0,1000. It will create a linear space vector. Okay, so after the creation of linear space vector, and we know that because this sample, that is this one is also a linear spaced no, it is not linear spaced. Okay, it is just containing 700 as a value in it. Okay, because samples is just a variable here, so inside this samples variable we just have 700. Now this range 0,1000 and random dot sample. Now we will come towards this function, that is random dot sample. Sample function will create the what's called is the we can say certain random magnitudes. Okay, we don't know, random means that they are not biased. Okay, we don't know about them. Okay, and it will create a because noise is obviously a random thing. It is just like the hum in your background. We can't predict about the noise. Okay, it is just a random phenomena. Maybe there is some sort of a hum or there is some sort of other noises like Gaussian noises, so we cannot predict anything at all. But here this function, that is random dot sample, will just create a what's called is the random samples, and then our np.asArray will convert them into an array shape. Okay, into an array shape. And why we are multiplying it with 0.0008? Because noise is always having a very less magnitude. So if we used to multiply it with this number, the magnitude used to be less. Okay, and it will like what's called is it will fulfill our requirement of low or less magnitude. After the noise is created, we need to move further. We will go for like out. Why out? Okay, so in this way we will like we will go for our what's called as, in order to make a sine wave, our input signal, because noise used to combine with this input signal. So we will write y out is equal to np.sine and 2 cross np.pi cross frequency. Okay, and multiplied with x input, x underscore input. Okay, why we have done this? Because we know that if there is sine, obviously there is theta. Okay, that is, and theta is equal to 2 pi f and t. Okay, 2 pi ft, and obviously x underscore input is actually time. We can say that because the signals used to be obviously designed on time, because time is an independent variable, so signals must have it's like this 2 pi f and t. Okay, so 2 pi f t and divided by frequency sample. Okay, we have to divide it with the freq sample underscore sample. So now this is our equation for output signal. Okay, but noise, now this is noise and this is our output signal. But either can we plot it out? Yes, we can plot it out. plt dot plot x underscore input comma x underscore input comma like y underscore out. Okay, obviously x okay, x must be on x place and y must be on the y place. Okay, so this is x comma y, just like time comma amplitude. Okay, so we will write plt dot show, and show will create a plotter graph for us. So plt dot show. Okay, it's a range. Okay, yeah, we have a little problem in spelling, so here a range function must be with AR, A and G. Okay, now you can see that our input signal is there, but it's not having any sort of noise in it. Okay, now what we need to do is to add some noise in it. So we will write plus noise. Okay, noise is always needed to be added rather than multiplying or any, because noise used to add with the input signal. So now we will, when we will use to write like this. Okay, now you can see that our signal is highly noisy. Okay, so in this way we can add and show the noise within a signal inside the Python. So hopefully you got the concept. If there is any sort of confusion, you can comment down and I will respond in no time. So thanks for visiting our channel and don't forget to subscribe.